Well, this is my first project with the MSP430, the launch pad here. Chip's been taken out and put onto a separate circuit. Just want to go over some of the hardware and things I learned along the way as far as that goes. It's really pretty simple. There's the main circuit, power supply, speaker, and I've got a 13-tone keyboard here, so full scale. Got some white buttons for the white keys on a piano and black keys. There's also range changers that are dynamic. If I'm holding a note, I can go up or down. So that's the lowest note, and that would be the highest note. This would be the highest range. So 7 ranges and 13 keys per range, so that's actually 91 different tones, though I guess there is overlap between the C to C here. So about the same range as a piano, roughly. Of course, it's monophonic. There's no chords, but you can be pressing a second key as you're letting off the first one and keep a continuous flow going. You can get a chord effect just by jiggling the notes, of course, but that doesn't really count. So really pretty simple for what it is. Wanted to quickly go over my most recent addition, actually. This is a LM1086 low dropout positive regulator to drop things down to 3.3 volts. As you can see, we've got roughly 4.5 volts here. That's being dropped down to a consistent 3.3 volts. If I add another battery, by the way, oh dear, should probably unhook that first, but it's not a big deal. There we go. What I use to make my four battery pack be able to work with fewer batteries, these are just anchors, the kind you push through a hole like on the ceiling, and then they hold things up. It happens to be the exact right width, and it's flexible, so it kind of springs itself back against the contacts. I have 2 of those, so it's actually a silly little thing I found out. But if we bring this up to 6 volts, you hear the test tones, and we're started again. There's no reset button on here, as you would have if you still had the chip in the launch pad, but the reset is wired high through a resistor, wired to VCC. So if I pulled that resistor and put it back in, that would reset it, but it's just as easy to cycle the power. Other bits and pieces, this is an LED I pulled out of a toy. Toys are great. Had the old, kit of jumper wires when I first put this together, but once I decided I was going to devote this board to that, I just made my own jumper wires here. Green are for all my notes. I put things in order as much as I could as far as the notes. We'll see when we look at the program why that's helpful. Starting at pin 2 and wrapping all the way around to pin 11, 12, 13, 14. That was the best sequence I could come up with, because then you get into your reset buttons and your test button, and of course pin 1 is devoted to VCC, pin 20 is devoted to ground. I am actually using pin 19 to take my audio out, where it runs through a 10K trimmer and a 200 ohm resistor, even when the trimmer's fully open. So that's how it gets enough of a tone to hear. I believe it is actually drawing somewhere maybe 3 to 5 milliamps of current, which is not good for anything long term. I think 1 to 1.5 milliamps is still kind of a lot for the pin, but I've done it without a resistor before, and with 100 ohm resistor, to the point where when I tested it, I was drawing maybe 20 milliamps, maybe even as high as 30. and I didn't burn anything out. In its current incarnation, I shorted one of the notes and just let it play for, must have been an hour, and nothing happened. Nothing got hot, nothing burned up. But my next project will probably be to replace this area with, or have a pullout to add a better little bit of amplification where I can just send the straight signal, the lowest draw possible, and then have everything behind, some sort of amplifier, IC, or transistor-based sort of amplification. So, but everything works now. Like I said, this is now on 6 volts, and this brings it down. This was a free sample from Texas Instruments. It brings down 5, 6, and 9 volts to exactly 3.3 volts. It's just a wonderful thing. So if I take this out, try just a good old 9-volt battery. Don't have very good leads on here. Now we're just running off a simple 9-volt battery, and that knocks it down to 3.3. Everything's perfect. So another thing we'll see in the code is built in a couple secret keys, Easter eggs. If you hold down these 2 keys at the same time and then do this, this is a testing every single tone with a small delay in between each one. And here's, I'm a fan of The Who. This is Quadrophenia. So that's kind of fun. I could add any number of extra things, but of course it just takes more memory. This all clocks in a little under 4K in size. This is the what is it? You read this here. That's the 2452 chip that comes with the launch pad. The other chip they give that can handle 8K of flash. So I'm under half of what that can handle. And plus I got some free samples of those as well. Texas Instruments, very, very cool. Price of the launch pad has recently gone up. There's some controversy about that, but was always $4.30 to go with the 430 motif, I guess. Now it's $9.99. For only $3 more, you could get a Stellaris launch pad, a much beefier chip. But the chip is not, it's not a socket. You're not able to pop it out as easily. And I believe that chip is not as easily to acquire, through other means other than buying it in bulk. But still, some fun toys, Arduino-like toys that you can mess around with. We'll get more to the code later, because the one thing you can't see, this also drops into low power mode after a given idle cycle. I'll fire up the voltmeter later in ammeter mode and show that dropping down. But for now, this is all the hardware, and I'll take everything off here so I can get this a little closer to the camera for you. I'm not sure about my angle here, but this is the whole circuit. You can see. Again, this is the voltage regulator, so power comes around. VCC's right there, ground's there. Everything else is basically just the wiring for the different keys to come into all the different pins. Reset. Later on, I'll also show having it hooked up, hooking up reset and test, and powering it from this, such that I can flash the chip even now that it's embedded on this other breadboard. So that's kind of nice. So that's the hardware and circuitry. We'll get more into low power mode and other nuances of the program by just doing a session on my Mac where I go over inertia. That's the MSP430 version of the Arduino environment, and it's running great on my Mac. I've done all the programming on that, so that'll be a vid for another time. Thanks.